Hi, in this video I will be showing you how to use your right hand to apply the right hand rules to determine the direction of the magnetic force. So in this question we will be focusing on the positive charge within a uniform magnetic field. I have here a positive charge with a direction of velocity going to the north and the magnetic field going to the east. So to determine the direction of the magnetic force, what I'll do, I will use my right hand and the thumb will be going with the direction of the velocity. My four fingers will go with the direction of the magnetic field, but my hand palm will be going into the page. So it's going directly into the page, which is the direction of the magnetic force. This way we can put an X and we label it as a magnetic force direction. Okay, now we have another one. I have here another scenario where I have a positive charge going into a magnetic field, a uniform magnetic field with a certain velocity. Now, in this scenario, the magnetic field going into the page, I need to determine the direction of the magnetic force. Once again, I will use my right hand rule or my right hand, and in this here, the V, which is my thumb going to the north with the direction of the velocity, my four fingers will go into the page, where is the direction of the magnetic field. That will leave my hand palm going to the west or to the left. That will be the direction of my magnetic force acting on this positive charge. Once again, the thumb going up with the velocity, my four fingers going into the page with the magnetic field, my right hand palm is pointing to the west or to the left, where is the direction of the magnetic force will apply. One more. I have another scenario where it's saying a positive charge moving with a constant velocity enters a region of a uniform magnetic field pointing out of the page. What is the direction of the magnetic force on the charge? Okay, for this one, you need to pay attention that the direction of your magnetic field is going out of the page. So, but we're still applying the right hand rules. Here we go. Now, once again, my velocity or the direction of the velocity going to east, that's my thumb. My four fingers pointing out of the page, just like this. That will be the direction of the magnetic field. That will leave my hand palm pointing downward or to the south. Once again, here we go. My thumb going with the velocity to east or to right. My four fingers pointing out of the page or toward me or toward to the camera. And that will leave my hand palm pointing south or downward. So that will be the direction of the magnetic force acting on this positive charge. Another one. This one here, saying again, determine the direction of the magnetic force acting on the proton. Here I have my magnetic field going out of the page, where the velocity of the proton going into the page. So theta will be 180 degrees. Now we know the formula for the magnetic force. It says Q times the velocity times the magnetic field sine theta. And because of theta is 180 degrees, that will make it 0. There is no magnetic force, or this magnetic field will produce no magnetic force on this proton as long as this proton moving within an angle 180 degrees to that magnetic field. Okay, that's all about some examples related to a positive charge within a magnetic field. In the next video, I will be talking about negative charge going through a magnetic field. Thank you.